Well, Sir Isaac Newton saw the problem with expense by using mirrors. He found that mirrors could be made large and inexpensive, so he came up with a reflector-style telescope, which a reflector-style telescope uses a mirror in the back of the telescope and a mirror in the front to focus and then present the light at the eyepiece. Like I said, mirrors can be made inexpensively. It's not uncommon to see a 10-inch reflector telescope still be in the $500–600, less than $1,000 range. The problem with another problem with both refractors and reflectors, though, is, like I said, to get magnification, you have to have a long focal length. That long focal length means, at least for these two, the telescope's got to get really long to hold all that light path. So then somebody came along and invented the catadioptric telescope. Catadioptric telescopes use mirrors, and they bend the light twice. The light comes in, hits the mirror in the back, it focuses on a mirror in the front, which then focuses out the back of the telescope. That allows me to have a relatively small telescope with a high magnification power. Since the telescope is still using mirrors, it's still inexpensive to make. This particular model of a catadioptric telescope is sort of a hybrid in that it's got a corrector lens in the front of it that helps correct some light problems that are inherent in the catadioptric design. Most telescopes will also have some extra pieces besides lenses and mirrors. Some of them will have star finders, which allow you to easily locate objects in the sky. The goal is that, having aligned this properly with the telescope, I look through this that has little or no magnification, shows me a big section of the sky, I find the star or the object I'm looking for, put it in the center of that, which then, hopefully, if I've done my work, is now in the center of the telescope. And the reason that's important is most telescopes, even at relatively low magnification, it's like pointing a straw at the sky. It's a very small area of space. Trying to find anything with that small of an area is difficult. Most catadioptric reflector telescopes will come with a star diagonal. Now, the star diagonal's primary purpose, they also have other purposes, but primary purpose is to keep the eyepiece at a comfortable viewing angle. The secondary piece is that some telescopes won't focus without it, but we won't go there. We won't go past that. Like I said, it's to keep your eyepiece at because if the telescope's in an odd angle, I can loosen it up and move the eyepiece. If it had an eyepiece in it. Of course, we talked about eyepieces. This is an example of an eyepiece. This eyepiece has multiple different focal lengths, so that way you can have multiple different magnifications with one eyepiece. Now we get down to the mounts, or tripods as some people like to call them. Now, unfortunately at night, out here you'll only see what's known as altitude azimuth style mount. And what that means is that to track, you move in altitude and azimuth through the sky to track the object. It's a simple, easy way to track objects, but it's, as you can imagine, it's a stair-step motion, so it's jagged, it's not smooth, you're having to fiddle with two different directions. But it's simple, it's easy to make a telescope in that manner. The other type of telescope is known as the equatorial mount, or the other kind of mount is called equatorial mount. And what it does is, to keep it simple, you align with Polaris or the North Celestial Pole, and then as you find your object, you only have to move one piece of the telescope, and it tracks smoothly across the sky. Now, alt-azimuth telescopes have another issue with the way they view, in that over the night, the objects in the sky tend to look like they're rotating. In other words, if Orion was coming up in the east, by the time he sat down in the west, he'd go from his head. He would go from standing up straight to sitting on his head in one of these style telescopes. Equatorial, it doesn't have that problem. It's the way it moves the telescope. Now we'll go on to a little bit of safety. Some people like me, like to look at the sun, which we can't do now because it's set. But if you ever look at the sun, There's only one real safe way to look at the sun with a regular telescope, and that's with a solar filter. This solar filter blocks 99.99% of the sun, or 999% of the sun, and what little it lets through still provides a nice bright image and lets you see safely. Some telescopes come with a solar filter that's designed to screw in the end of the eyepiece. Don't ever use one of those. Light focused by telescope can melt plastic, can melt metal, can even melt glass if it's pointed at something long enough. And one of the best examples that show you how dangerous it is, on YouTube there is a video where a museum director took a telescope and a grape, pointed the telescope at the sun, put the grape behind it, and vaporized the grape. And if you think about it, let's put the grapes right there where the telescope's focused at, which is also where the eyepiece is at, which is where you're going to put a piece of glass that's going to protect your eye, where it can be heated, either break or vaporize. Then what happens? There's nothing between your eye and the sun anymore. Your eye is now the grape. So don't ever look at the sun without a proper fitting, tight fitting, front mounted solar filter. Let's see. Wow, I'm moving awfully quick for this, ain't I?
That's okay. That way we can give away pictures this time.
Yeah. Oh yeah, and I hope y'all were able to keep up, because I've got some photos to give away at the end of this to those who remember. This is an example of an amateur radio telescope. Now, a radio telescope, for all intents and purposes, is nothing more than an antenna designed to pick up radiation. This particular one picks up in the 12 gigahertz band. It can detect what's known as black body radiation, or heat, for lack of a better term. This is a complete amateur radio telescope in that this is a tuner and receiver. The antenna's here, and the dish just happens to help focus the radiation. NASA has fields, radio telescope fields. They're huge, but they're basically the same thing. Of course, they've got much more sophisticated receivers and tuners, but you know, when you distill it down, that's basically a radio telescope antenna and a receiver. If this one was working properly, I could have pointed at the sun, or I could point at the moon, and it would beep and let me know it found it. Unfortunately, I haven't gotten that one completely tuned yet. Do we got any questions? Any of y'all have telescopes? All right. What kind of telescope you got? See, I've seen some other. You said you got one? What's it like?
9,000.
Okay. And you? How about you?
I just have a question.
Okay.
Does it have a built-in solar panel,
How do you mean? What do you mean?
or like the solar panel is already built into the sun?
Oh no, it's not. No. You mean solar panel as in power, or as in, or
Or do you mean a solar filter?
It's a solar filter.
Oh no, I have well, not for that particular one, but I have one for my 8-inch telescope at home. But you know, I made it. They do sell them for that model, but this one doesn't. That's why it's pointed away from the sun. It's actually pointed at the moon, which you can't see because of the clouds.
Go ahead and ask some questions.
Any other questions?
What is that device for on the telescope?
Oh, this right here.
The thing with
The remote.
Oh, this is actually the control panel for the telescope. So this is a fully automated telescope. Like if I'm going to tell, I'm going to go, I said solar system, and I say I want to see, where's Mars at tonight?
200 trillion. Oh, that's pretty cool.
And it'll go right to it.
Now, do you have to tell it where it's pointing initially? Or?
Yeah, you have to, like before we started, I pointed it at the moon and told it the moon's here.
Okay.
And then it's got a map inside itself that says, okay, I know that Mars is X number of steps over, X number of steps up or down, and it goes there.
So more or less is when you tell it where it's pointing, you tell it what day it is.
Yeah,
You have to do
day
that.
and time. Yeah.
That's pretty cool. How much is one my pet?
It's about $1,000.
Good money.
With your solar filter, can you still see the solar flares pretty clear?
Now, to see solar flares takes a special solar style telescope, which we don't have out here.
Okay.
We do have one in the club, but you have to be able to view hydrogen gas, which is, that's what
Right.
the sun's fusing.
I didn't know if you could see the.
Now, this basically shows visible light, which which is wild.
But you can see the sunspots on it.
Yeah.
Like in that one, it shows a white ball, but then it shows black little dots.
You're actually the spots.
Go ahead and ask questions.
Okay.
I'm gonna give you these so you can let them pick, and I'm gonna go over and let him do
Okay.
these.
Yeah, see if they pay attention.
Yeah.
Well, now we come to the quiz
Put them
part.
on the table.
Lay these out so y'all can look. And they'll come up here. No popcorn. Okay. I realized one thing I forgot to go over, so I'm going to cover that. We'll get to it. But, who remembers what kind of mountains these are?
Or like something else to know.
There's another part to it.
You know, it's not the official name, but some people
Well, they're all these two are tripods, but the actual mountain they use is a different kind of name. Okay. All right. What is the focal length of a telescope? All right. Come over here and pick you out a photo. What does this piece do?
It's a star map.
No?
It allows you to line up where you see a group of stars or something you want to see. That way, then you can view it with a telescope.
Perfect. Come over here and pick you a photo. Let's see. What does this style if I can talk. What does this style telescope use to focus the light?
A solar panel.
No?
Here.
Yep. Come over and get you a photo. Let's see. Who invented this topic?
Sure, as you can.
Yeah. Come over and get you. I got 3 left. What's this piece right here?
It's detects radiation.
All right, what's it called?
Um,
Okay, come on up here and get your photo. You knew what it did. I'll take that. Let's see. Where should you never put a solar filter? Which end?
what's that big red dot on that?
That's where it should be. Where should you never put one?
Up there, the wings on it.
There you go.
Up there, the wings.
All right, we got one. We'll have one like that.